Hello, my name is Alexander. I did a bridge for my assessment and I'm doing Material Worlds Stage 3. So first, we visit the concepts of material with students posing the question, what is material? And distinguish between objects and material from which the object is made. For example, a door is an object while wood is material. We explain observable materials and how distinctive characteristics can be identified. For example, bendy, stretchy, stiff, durable, hard, transparent, and waterproof. We look into different forms of binders and how easy applicable they are to different materials like glue, blue tack, and tape. We begin to probe questions as to what materials students think should be used for a bridge. For example, why is steel used in a bridge? When should plastic be used? Where is rope used? In this activity, we look for 3 particular materials and the characteristics. These being metal, wood, and stone. Furthermore, we discuss Aboriginal perspectives and how natural materials were used in the act of bridge making. We look into traditional Aboriginal bridges and why they're important, what kind of makeup of these bridges, and we have students guess the materials that were used in these bridges, looking for things like wood, branches, logs, woven fibers, leaves, stone, and mud. So then we're going to look into different materials affected by weather conditions. So metals, when prolonged to sun and rain, can weaken over time. This is especially true for conventional steel, which can rust and corrode when exposed to moisture. Students will learn the difference between conventional steel and stainless steel, understanding that stainless steel is more sustainable due to its higher resistance to rust and corrosion, making it more durable in harsh weather. Some materials like wood are more absorbent. When these materials are exposed to rain, they can absorb water, leading to swelling, weakening, and ultimately losing their ability to support weight. This demonstrates the importance of choosing materials that can maintain their structural integrity even when wet. Heat can also have a significant impact on materials. For example, plastics and certain adhesives like glues can weaken and degrade over time when exposed to high temperatures. This can cause structural failures in bridges, and this highlights the need for heat-resistant materials in construction. Students consider the bridges they've come across either from traveling or the internet, even smaller bridges in their local environment. Students will identify and pose questions about why certain bridges are stronger than others. We will look at pictures of famous bridges in the world and why they have particular designs. And I ask the class particular materials and shapes they use to provide support, ranging from the truss bridge to the Golden Gate Bridge to the suspension bridge to the arch bridge. Here we talk about why bridges are important and the common designs of bridges and why they're important to the local community. I discuss with students the importance of fair and safe working conditions in the construction industry and emphasize how ethical labor practices contribute to economic growth and community well-being. For example, I highlight how bridge building projects can create jobs and stimulate economies. I would also mention long-term sustainability of the bridges and encourage students to consider the environmental impact of their materials and design choices to ensure the bridge's durability in the long term. So here we are working scientifically. Students will begin by identifying key scientific questions such as how different shapes and materials affect bridge strength and durability. They will plan and conduct experiments to test these hypotheses, observing how their designs perform under various conditions like weight load and weather exposure. Drawing inspiration from real-world examples, students will produce detailed labeled drawings of their bridges. They will consider both functional and aesthetic aspects of their bridges, ensuring that they are not only strong but visually appealing. During this process, they will document their decisions to use technical terms to their design choices. So this would be the mini bridge experiment that we'll do in class. This will be done in groups of 4 as students will formulate which bridge designs and materials would be most effective. For example, they may hypothesize that triangles or rectangular truss support provide better support. Weather conditions will also be tested with water spray bottles to show durability of materials. Using their hypothesis, students will build small-scale bridges using different shapes and materials. They will experiment with various designs to explore their potential benefits and drawbacks. Students will record their observations, noting which shapes and materials perform the best in terms of weight support and stability. They will also assess how well different binding agents contributed to the bridge's performance. Students will prepare a brief explanation of their findings, discuss how materials and designs were most effective and why. They will explain on how their experiment informs their approach to the main bridge building assessment. So back to working scientifically, we will use age-appropriate, this is more for safety, where we'll use age-appropriate scissors and cutting tools with blunt ends. Students will receive clear instructions on how to handle these tools correctly, always cutting away from their bodies and fingers. When using hot glue guns, they will use low-temperature models designed for adolescents. I supervise their use closely and prevent burns, and provide guidance on safe handling, including proper use of the cord and unplugging the glue gun after use. I will warn students that if there is inappropriate and unsafe usage of glue guns, the activity will be cancelled. During class, I will be mindful of material allergies and provide alternatives if necessary. Make sure that tools and materials are handled responsibly and that students avoid bad behavior, especially in the work area. Additionally, students will be spaced to respect each other's personal space to prevent accidental injuries. So during weight testing, students must stand clear of the bridge and avoid placing their hands or feet underneath to prevent injury from falling weights. And students will be encouraged to wash their hands thoroughly after handling materials and tools. So planning and construction. Planning will conduct the tests to evaluate strength and durability of the bridges. It's important to emphasize that students will not be assessed solely on the weight their bridge can hold. Instead, the focus will be on the specific purpose their bridge serves and how well they've applied the knowledge and skills to constructing it. One key activity involves the weight underneath the bridge, and this will help see the maximum load that the bridge can support. In addition, we will simulate various weather conditions by exposing bridge to sunlight, rain, wind, using a fan to simulate wind, water, and sun for heat. And this will show students how different environmental factors impact the performance of their bridge to ensure that tests remain fair. Students will begin by identifying key scientific questions, such as how different shapes and materials affect bridge strength and durability. Using the experience they gained from the mini bridge experiment, they will plan and conduct experiments to test their hypotheses, thinking about how their designs will perform under various conditions like weight, load, and weather exposure. What I want to see is design choices from real bridges, drawing inspiration from real-world examples, whether from memory or lessons. Students will produce detailed labeled drawings of their bridges. They will consider both functional and aesthetic aspects of the bridge, ensuring that they are not only strong but also visually appealing. During the process, they will document their decisions and use technical terms to communicate their design choices. These, for example, stainless steel, rectangular, truss design, support beam like piles, different kinds of binders, as well as sustainable recycled materials. So this assessment working model is to be built a bridge using the information that is taught in lessons from looking at traditional bridges. Materials will simulate real-world materials used in real bridge building. This assessment will be an individual task. Students will create detailed project plans that take into account the resources available when working on design solutions. Project plans will be graphical drawings of bridge designs. Students also need to think about what resources are available and how to use them efficiently. For example, if only limited materials are available, the plan should reflect how to use them wisely without waste. The 3 outcomes that I've chosen have been assessed, and this is my marking rubric assessment. Thank you for watching my assessment.